Hello everyone. We are a batch of students from Biomedical Engineering Department, SRM University, Chennai. I, Arbachina Bora, along with my batchmates Yonten Jamsho, Shan Jalu and Furkan Farooq Lone, is doing our final year project in detection of strabismus or squint eye using Adaptive Neuro-Fuzzy Interface System or Anfis under the guidance of Mrs. T. Rajalakshmi, Assistant Professor, OG. Strabismus or squint eye is the misalignment of the eye with each other. It is also known as cross-eyed or wall-eyed. It typically involves a lack of coordination between the extraocular muscles which hamper binocular vision. Strabismus occurs in 4% of children, amounting to 130 to 260 million worldwide. The different type of strabismuses are esotropia, eye turned towards the nose bridge; exotropia, eye turned towards the ear; hypertropia, eye turn upward; and hypotropia, eye turn downward. Strabismus, if not cured at a younger age, causes vision loss or impairment. Also, the angle of deviation or squint is very necessary for the correct treatment by the doctor. People with such a condition have problem with work, school and sports. Also, it has a negative impact on the self-image. The already existing method for the detection of squint eye are real-time squint detection. In this, they have used digital image processing, projection function, half transform and non-linear enhancement and segmentation. However, distortion is caused in half transform makes iris detection impossible. The second method is called automatic strabometry method. Here also half transform is used. The approximate calculation time here is 2 minutes. However, the problem with this method is that it cannot be applied to blurred images. The third method is a neural network approach in which testing and training set of data is used. The problem with this method is that it cannot be extended for video images. The main aim of our project is to detect the angle of squint using Adaptive Neuro-Fuzzy Interface System or Anfis in MATLAB. Our objective is to detect the regions of the face and to find the apex of the facial triangle or the Delaunay triangle in order to find the extent of deviation of squint using Anfis. This is the proposed block diagram of our project. First, we load input images in the MATLAB. Then, left and right eye are separated. Various regions of the face like the eyes, nose and mouth are highlighted, and subsequently a triangle called the Delaunay triangle or facial triangle is formed with the center of the two eyeball forming the base of the triangle and either the nose or mouth forming the apex. A shift in the apex of the triangle roughly indicates a squint or abnormality in the eye. Edges of the eye are detected and the region of interest, that is, the eyeball, is extracted using half transform. The half transform is a technique which can be used to isolate features of a particular shape within an image. Feature extraction is done. Here, we have extracted the features, area, perimeter and circularity. Further, detection of angle of squint using the features is done using Anfis. This is the image of a normal eye. Here, we have extracted the facial triangle using markers. Marker 1 is the left eye, marker 2 is the right eye, marker 3 is the nose and marker 4 is the mouth. Edge detection is carried out to identify the region of interest, that is the iris, and then half transform is applied. The squint angle detection is carried out. Also, a GUI or a guided user interface is shown to show the flowchart of our program. Since there is no squint for this particular image, the squint angle appears to be 0. This is our sample image for squint eye. Here again we have provided Guided User Interface or GUI to show the flowchart of our program. This is the Delaunay or facial triangle we have extracted for detection of shift in the apex with the help of markers. Marker 1 here is right eye, marker 2 is left eye, marker 3 is the nose, and marker 4 is the mouth. Since there is a shift in the apex, we see that there is no alignment in the marker and it appears displaced. This is the edge detection of the squint eye, which is done to bring out the iris of the eye, along with which half transform is also done. This is the particular formula we have utilized for calculating the angle of squint. Squint angle is equal to 180 minus cos of length 1 multiplied by length 2 multiplied by 180 divided by pi. Pi here is 3.14. Also, length 1 is equal to square root of sum of area to the power 2, and length 2 is square root of sum of perimeter to the power 2. This is the squint angle detection for a sample image of an eye that has squint. Since squint is present, the angle recorded here is 2.21351. Also, a guided user interface is applied to show the flowchart of our program. The features extracted from the squint eye are as follows: area 160 mm, perimeter 3.1267 mm, and circularity 0.0611 mm. This is our final Anfis result. Here, training data indicate the left eye squint angle of all the sample images, whereas testing data indicate the right eye squint angle of the sample images. Both these data set are used to calculate the overall error value for a set of input abnormal images. In this study, adaptive neurointerfacing approach to detect the angle detection of squint eye are carried out for different cases of normal and abnormal subjects. The work is carried out in two different phases, training phase and testing phase. Then, relevant geometric features have been selected, and based on the geometric features, relevant parameters have been extracted. Then, using Anfis, the feature vectors have been utilized in the testing phase to recognize whether the eye is normal or squint, as well as angle of squint is also carried out. In the future, we will extend our work to video images. Also, we will deduce the relation of the additional features that includes circularity, sum of variance, entropy, contrast correlation, energy, and homogeneity, with that in reference to squint. Below given are the references we have used while carrying out our project. Thank you.